Hey guys, today section 3.1, we're talking about derivative of a function. See how much fun it's going to be? It's going to be great. So we're talking about how to use the limit definition of a derivative. It takes us back to chapter 2. We already did limit definition of a derivative, but we're going to take it even further in section 3.1. So we're going to start with that limit definition of a derivative. You're going to notice this notation, f prime of x. That means the derivative. And if you recall from last chapter, when we talk about derivative, that f prime, we're talking about instantaneous rate of change. So when we do the limit definition, it's that limit as h goes to 0 of f of x plus h minus f of x all over h. And we got that from doing y2 minus y1 over x2 minus x1. And if you need to still remind yourself, we're going to get better about it. We get x and f of x. And then our second point says move a little bit further away from x. And then we do f of x plus h. So this comes from finding the slope at that point. So it says if f prime exists, we say that that function is differentiable. You're going to see that vocab word show up everywhere. Just means that the derivative exists. And it says a function that's differentiable in every point of its domain is a differentiable function. Fair enough. All right, so example 1 says using the limit definition of the derivative, they want us to differentiate f of x equals x cubed. So like I said up here, if you need to, write out the ordered pairs. But if you can, let's try to just use this definition. So it didn't give us a point this time. They didn't say at x equals 3 or at x equals 10. They simply just said find the derivative at any given point. So we start with that limit definition. So we get limit as h goes to 0. And then we do the function at x plus h. That notation simply means take the function, plug in x plus h. So I'm going to take the function, which in this case is x cubed. Sorry, just got blurry there. And we're going to replace the x with x plus h. So we get x plus h cubed minus the function. And our function this time is x cubed. So minus x cubed all over h. Now, I want you to take a minute, pause the video. It's actually going to pause for you. But I want you to figure out what is x plus h quantity cubed. So I'm going to carry on. Limit as h goes to 0. What you hopefully have gotten at this point is that you get 1x cubed plus 3x squared h plus 3xh squared plus h squared cubed, just kidding, minus the function x cubed all over h. And our trick to make sure we've done this right is that that last term should always cancel out somewhere in here. And so we see there is a positive x cubed and a negative x cubed. Those go away. And then our other key that we've done this right is now all remaining terms should have an h remaining in it. And in this case, that happened. So I can now take an h out of every term. So that one's gone, gone. One of these is gone, and one of these is gone. So I'm going to rewrite my problem. I've got the limit as h goes to 0, and the terms I have left are 3x squared plus 3xh plus h squared. And now at this point, I don't have any weird h's on the bottom. I can now substitute in and plug in h equals 0. So 3 times x times 0 is just going to be 0, plus 0 squared is 0, so I'm left with 3x squared. So what you've just found is now we can find the derivative of x cubed at any point. If I wanted to know the slope at 7, I can plug it in. I would get 49 times 3. If I wanted to find the slope at -1, I can plug in -1. -1 squared is 1 times 3 is 3. Yay for those derivatives. They will help us find the slope at any point. Now, to find the derivative at a point, there is another definition that I want you to be aware of, and it says f prime of a at x equals a. They call this the symmetric definition, and they say the limit as x approaches a of f of x minus f of a all over x minus a. It's just our slope formula. It really is not any different than that one. Okay, but I just want you to be aware that this one does show up every once in a while. They ask you to use that particular one. You're going to see 3 different notations for a derivative throughout our textbook and on the AP exam, so just want you to be aware of all of them. The first one is one you're most comfortable with from pre-calc. You're going to see things like y prime or f prime of x. The second notation you may or may not have been introduced to in pre-calc, but that one you're going to get dy dx, or you could see something like df dx. That just stands for the derivative of y over with respect to x, or the derivative of f with respect to x. It's a pretty common notation as well. The one that's going to be new to you is number 3, and it looks like this, d dx of f of x. That simply says do the derivative with respect to x of some function. You may even see it written, I'll just put or, as d dx of the function y. So anytime there's a d dx in front of something, it means find the derivative of it. So if I asked you to do d dx of x cubed, we already figured that out up here. The derivative of x cubed was 3x squared. So I could just put equals 3x squared.